Yes. So,
Shall we start, sir?
yeah, one second.
Okay.
So, a very good afternoon to one and all. Welcome to 2 week student development program on Engineering the Future, moving from electronics design to industrial implementation, organized by Department of Electronics and Communication Engineering, Dayananda Sagar College of Engineering, Bangalore. Today, we have with us Dr. Smitha Gayatri D. She is an accomplished associate professor in the Department of ECE, PNMIT, Bangalore, with over 15 years of experience in teaching and research. Her expertise spans communication systems, signal processing, VLSI design, IoT, and cybersecurity. She earned her PhD from VTU, Belgavi. A prolific researcher, Dr. Smitha has published more than 20 research papers in reputed Scopus and IEEE indexed journals and international conferences. Her academic contributions include several book chapters, patents in AI-driven systems, and leadership roles in funded research projects. She is a dedicated mentor to MTech and BE students, regularly organizing FDPs, workshops, and hackathons. Additionally, she contributes as a reviewer and session chair for prestigious conferences. Her research interests focus on low power VLSI design, physical design, Verilog, and power line communication, driving impactful advancements in both technology and academia. A very warm welcome to you, madam. So today, uh, the topic of her presentation is From Idea to Impact, motivational session on broadband power line communication. Over to you, madam. Smitha, madam, you there? Ma'am, you can start, ma'am.
Yes, sir. Sir, thank you for the introduction. Good afternoon, everyone. Sir, my
Yes,
voice
ma'am.
is
Yes.
audible.
Yeah,
Can I
yeah,
start?
yeah, yeah, yeah. Please, please, ma'am.
Yeah. Yes. Good afternoon, everyone. To be here with you today as a speaker for this session. The topic which I have chosen is one that the innovative and rapidly gaining relevance in the modern communication system, that is broadband power line communication. In this session, we'll explore what is BPL, how it works, the underlying technology, its advantages, challenges, and the real world applications. So these are the things we are going to discuss in this session. Once again, I'm thankful to Swapnil sir for the opportunity. Shall we go with the session?
Yes, ma'am. Please go ahead.
Yeah. What is PLC? PLC is a power line communication, is a data transmission technology using existing power lines.
Madam, that slide is
As
not
you know,
moving.
as we know that.
Madam, that slide is not moving.
Okay. No, sir.
Oh, no, madam, it's not moving.
Okay, so 1 minute. Sit down.
Uh, yes, madam. Now it is moving.
Power line communication is a data transmission technology using existing power lines. Using existing cables as a transmission line can build a network in a short construction period and a low cost. Power and data can be transmitted with a single cable. No new wiring of a communication cable will be needed in a network, that is PLC network. Low voltage power lines are found in most of homes around the world, and it can be used in a provide internet access, helping to solve the last mile problem in communication. The figures will clarity that how the PLC will be accessed inside the home. Uh, This slide says about the power line network, power supply networks, in which the electrical supply system consists of networks levels that can be used as a transmission media for the realization of PL networks. The one, high voltage, where the range is between 110 to 380 kilovolts, and the medium voltage. Second is going to be the medium voltage level, where the range varies from 10 to 30 kilovolts, and the last one is going to be a low voltage, where the range varies from 230 volts. In USA, it's going to be 110 volts. So as in case of high voltage level, the network connects the power stations with the large supply regions or a big customers. High voltage networks are usually realized with the overhead supply cables, where in case of medium voltage, the network supply larger areas like cities and big industrial or commercial customers. The medium voltage networks are realized as both overhead and underground networks, where the span distance are significantly shorter in the high voltage networks. In case of low voltage, as I said, the voltage varies. The voltage level is going to be around 230 volts. Network supply the end users either as individual customers or a single user of a bigger customers. Their length is usually up to few hundred meters. In urban areas, the low voltage networks are realized with underground cables, whereas in rural area, they exist usually as overhead networks. As in a home electrical installation belongs to the low voltage network levels. As you can see in the diagram which I showed, it's a structure of electrical supply network where internal installations are usually owned by a user. They are connected to the supply network over a meter, that is unit which I mentioned is M. In the diagram which is mentioned is M, that you can visualize in the figure which I showed in the slide. On the other hand, the rest of the low voltage networks belongs to the electrical supply utilities. The low voltage supply networks directly connect to the end users in large number of households worldwide. Therefore, the application of PLC technology in low voltage networks seems to have a perspective regarding the number of connected customers. On the other hand, I can say this, low voltage network covers the last few hundreds of meters, the customers and the transformer units. And it offers an alternative solution using a PLC technology for the realization of so-called last mile in the telecom area, access area. So we are going to discuss about the standards. What are the standards are involved? The bands for the power line communications. You can see in the table I mentioned the bands and frequency ranges and the maximum transmission amplitudes and which are dedicated for the particular bands which are dedicated for. You can see there are three bands A, B, C, where A, the frequency range of the band A is from 9 to 95 kilohertz, where in case of B it is 95 to 125 kilohertz, where in case of band C it's between 125 to 140 kilohertz. So maximum transmission amplitude, it varies for different bands. That A carries around 10 volts, where B carries 1.2. Similarly, C carries 1.2 again. Okay, so the as per the usage of the application, where A involves with other utilities and B and C for the home. So based on this, we are going to categorize the complete PLC network into two, that is narrowband as well as a broadband. So in case of narrowband, the narrowband PLC network operates within the frequency as specified in the table, that is CELNEC SCNELEC bands. We are going to call it as this is the particular band. As I said, there will be divided into three bands, that is A, B, and C. The frequency bands B and C are mainly used for the realization of building and home automation. The narrowband PLC system applies both narrowband and broadband modulation. First, narrowband PLC network have been realized by the usage of the amplitude modulation, that is ASK. The ASK is not so robust against the disturbance, therefore it is not suitable for the application of PLC networks. Then we are going with a BPSK. BPSK is nothing but binary phase shift scheme. First scheme, and therefore is more suitable for the application in PLC system. However, in case of BPSK, phase detection is necessary for the realization of the scheme. seems to be complex. BPSK based systems are not commonly used. Most recent narrowband PLC systems are going to be FSK, which will be reliable for the modulation process. Similarly, as I said, there will be two systems which we are going to discuss. There will be two systems, PLC systems. One is narrowband as well as broadband. As in the previous case, already said, 3 bands are reserved with the frequency ranges from the kilohertz, where it start from 9 to 140 kilohertz that occupied by the narrowband. Similarly, in case of broadband PLC, where the data rate is high, it will be more megabits per second. It's compared to narrowband PLC, compared to, as I said, NPLC. So broadband PLC system provides significantly high data rate than the narrowband PLC system, where the narrowband networks can realize only a small number of voice channels and data transmission with a very low bit rate compared to broadband PLC. So as I said, broadband PLC network offers a realization for more sophisticated telecommunication services such as multiple voice connections, high-speed data transmission, transfer of video signals, and narrowband services as well. So therefore, these PLC broadband systems are also considered as capable of telecommunication technology. Most capable telecommunication technology is broadband system, that is with respect to the PLC. Okay. So this is all about the categorization with respect to PLC, that is narrowband as well as broadband. This slide gives us a clarity that how the connection is going to be existing, that is PLC access network. In this network, sir, any issues? It's going well?
Yeah, ma'am. I think some student was doing something. Anyway, I have removed him. No problem.
Okay.
Go ahead.
So as you can see, the multiple connections with respect to low voltage power supply networks, there is a base master station, BS. We are going to name it as a BS, base master station, and a transformer unit, and we have high or medium power supply network and a backbone telecommunication networks, where we are going to exist a interconnection between the telecommunication network and the PLC access network. Okay, this is outdoor connections and the in-home connection. How we are going to make connection between this telecommunication network with respect to the PLC network. So this complete figure gives us the structure of a PLC access network. So we are going to discuss how actually the connection exists and how we are going to access the broadband service at home by using this existing infrastructure of that is power line. Through this, how we are going to access the broadband service, that we are going to discuss through this diagram.